ورحمة الله وبركاته. طلاب الفرقة الثالثة كلية التجارة جامعة بورسعيد. I am going to talk about two models: economic order quantity and production order quantity. EOQ is the number of units that the company should buy to minimize the total cost, such as holding cost, ordering cost, or shortage cost. To calculate the EEQ, you should know the following cost: holding cost, ordering cost, setup cost, shortage cost. There are some assumptions of EEQ. Demand and cost are constant. Orders are delivered at once, no late. No stock out are allowed. Example: annual requirements of item X equal 1,800 units, holding cost $4, ordering cost $100, cost per unit $10. What is the EQ? We have two ways to calculate EQ. First one, we can use table like this table. Second one, equation of model. This table has 6 columns from 1 to 6. First one, number of orders. We assume number of orders start from 1 to 10. Second one, quantity. This equal annual demand over number of orders. Annual demands 1800 over 1, 1800 over 2, 1800 over 3, 1800 over 4, and so on. Average inventory. This should be beginning quantity or beginning inventory plus ending inventory over 2. Beginning inventory, this will be quantity, column 2. Ending inventory, in this model we assume we have no stock. This means ending inventory will be 0. So quantity plus 0 over 2. We can say quantity over 2, column 2 over 2. Holding cost, this will be equal holding cost per unit 4 in our exercise times column number 3. Ordering cost, this number of orders times S ordering cost per unit equal $100. So this column times $100. Total cost, this will be equal holding cost plus ordering cost. We can realize the lowest cost here, 1,200. This means we recommend to buy 300 units. And we can realize also, if you buy 300 units, holding cost will be equal with ordering cost, and the total cost will be the lowest. We can assume if you buy another quantity, not 300, we can assume if you decide to buy 225, the cost will be 1,250 more than the total cost here. If you decide to buy 360, total cost will be 1,220, is bigger than 1,200. Another method to calculate EEQ, see the next slide. EEQ here, EEQ will be equal square root 2 times D, demand, S, ordering cost, over H, holding cost per unit. This ordering cost per order, demand, annual demand, H holding cost per unit. This will be equal 300 units. This is the same answer we reach from the above table. This diagram also so important to understand the EQ model. We can realize this X for quantity and another one this for cost, and we have two types of cost, holding cost and ordering cost. Holding cost, the relationship between holding cost and the quantity should be positive. If you buy more quantity, holding cost will be go up. This makes sense. But the relationship between ordering cost and the quantity should be negative. The optimal solution we can reach LEQ here, because holding cost equal with ordering cost, and the total cost, the lowest point in this curve will be here. Just diagram showed you the relationship between holding cost, ordering cost, and the quantity. As I mentioned before, demand and the cost should be fixed. But here, when we talk about discount, this means the price will be go down. So discounts break the assumption of EQ model. We have two types of percent or discount, First one, discount in percent form. Second one, different prices for different quantities. Just to remind you, the total cost will be equal holding cost plus ordering cost plus the cost of purchasing. Here, ordering cost equal demand over quantity times S. Here, holding cost Q over 2 times holding cost per unit. Purchasing cost, demand times cost per unit. This information in this slide is so important for you. Just summarize what I said about discount and EQ model. Still, this slide talks about the relationship between discount and the EQ model. See the following information. Demand is equal 18,000 units, ordering cost 20, holding cost 2, cost per unit 10, and you have quantity discount as is scheduled. 2% if you buy quantity from 1800 to less than 3000. 3% if you buy quantity from 3000 less than 6000. If you buy 6000 and more, you will get discount 4%. What is the best option? To answer, you should calculate total cost for EQ and the total cost for each discount. First, total cost for EQ. You can get EQ according to this equation will be equal 600 units. The total cost for EQ, you can apply on this equation. As you can realize from this, the total cost will be 181,200. Then you calculate total cost for each discount, as you can see in next slide. Second, we should calculate total cost for each discount, as you can see from this slide. First one, 2%. You can apply the equation. Total cost will be equal demand over Q. But here, just remind you, Q for this exercise, we get EEQ 600 units. But here, we use 1,800. Why? Put on your mind, if you use discount, don't use EEQ here, but I will use the lowest quantity. If you return to your exercise, you can see 2% for quantity from 1,800 to 3,000. So I will use the lowest quantity, 1,800, times ordering cost plus quantity, this quantity, over 2 times holding cost per unit, plus purchasing cost demand times 10 this price or cost per unit, times here times discount. Discount you will take 2%. This means 100 minus 2% will be 98%. 98%. The total cost will be equal like this. And you can see how can we calculate this number. Second, the total cost for the next discount. 1 second to get laser. For the laser here, 1 second, sorry. For total cost for 3%. And the lowest quantity will be 3,000. Total cost will be 18,000 over 3,000. This not EEQ. As mentioned, we use the lowest quantity, and you can complete the rest of equation. This the rest of discount, because I will take discount 3%, so I will pay 97%. Also, we can calculate total cost for 4% here, and the total cost. Then we have now 4 total cost. First one, total cost for EEQ, total cost for discount 2%, total cost for discount 3%, total cost for discount 4%. Then you should choose the lowest total cost. The lowest total cost, we can see the lowest total cost for 3%. This is the lowest one. This means we recommend for this company to buy 3,000 units to reduce the cost to be 177,720. This. Just read this conclusion and understand each point. Form of discount, different price with different quantities. You can see from this exercise, demand will be equal, just use the laser, 3,600. Ordering cost is 100. H will be 20% from the price. And you have these prices with quantity. The price will be $12 if you buy quantity less than 300. The price will be $10 if you buy from 3 to 500. $9 if you buy 500 to 800. What's the best option? For this exercise, first step, you calculate EEQ for each price. Why I said here for each price? If you return to your exercise, you can find H equal 20% of each price. This first. Second, calculate total cost for each price, then select the lowest total cost. We should apply 3 stages, what I said before. First one, calculate EEQ for each price. First price 12, EEQ will be 548. Price 10, 600. Price 9, EEQ 632, and so on. You can realize something here. You would like to buy 548 with price 12, but supplier will refuse because he said, return to your exercise, he said less than 300 with price 12, but you would like more, so he will refuse this. If you ask him to buy 600 with $10, he will refuse because $10 from 300 to 500. 632 he will accept because he said $9 with the quantity from 500 to 800. So we start from here. So we need to calculate total cost for price 9 and the lowest price as well. What about above? Ignore the above here. So we start from here until 8.5, 8.25, 8.15. As you can see, the total cost here. This total cost for 9, for 8.8, and so on. The lowest total cost here, 30,990 with price 8.25 and quantity 661. This is the optimal solution. You have some exercise here in this slide, just theory, talk about true or false. Next one as well, MCQs. This first exercise, try to find the best option for this exercise. Exercise 2. Last exercise, try to find the answers of this exercise and you can send the answer to me by email. We can move to another topic now. Second section, production order quantity model. Before I talk about this model, I would like to give you or talk about make or buy consideration. Reasons to make instead of buy. Quantities are small. Quality requires a special technique. Preserve technological secret. Take advantage of unused capacity. Avoid supply dependency. We have reasons to buy instead of make. Lack of administrative or technical experience. Problems maintaining technological leadership. Shortage of production capacity. More flexibility. Superior supply management expertise. Lower overhead cost. Now we have two models. First one EEQ, second one production order quantity model. We use EEQ if you buy, but if you would like to make your needs, you should use production order quantity. Now we assume the company prefers to produce its needs. We have some assumptions of production order quantity. Demand rate is constant. Production rate is larger than demand rate. the production lot is not received suddenly, there is only one product to be scheduled, the rest of EEQ assumptions stay in place. Some rules you should put on your mind to calculate easy POQ and other indicators for this model. POQ equal to ds over h times 1 minus d over b. B, this production per day, D, demand per day or use per day. Or we have another equation, BOQ as well, equal square root DH over S, or we can say this EEQ times the square root B over B minus D. Total cost for POQ, this will be equal setup cost plus holding cost. Setup cost D over Q times S, but put on your mind Q here, not EEQ, but Q for POQ, plus half Q brackets 1 minus D over B times H in all this number, times H. From here to here, this average of inventory, this without half, this maximum inventory. This diagram shows you some information. First, this company produced number of units, and it's the same day they use another numbers. B, for example, you can say 100, but use per day 60. So the inventory will be 40. 100 minus 60 will be 40 per day, this inventory. Then when your production or inventory reach to maximum inventory, you stop to produce and you try to use the products which is your stock until reach to the zero. Then you can start to produce another lots like here. This area we call this production time. This area we call this production time or T. Production time or T, this will be equal Q over B. Q over B, production time. Here, time width, which is the time when machines are not busy. Here, no production here. So, machine stop, not busy here. This will be equal Q over D minus Q over B. Q over B, put on your mind this T. From this point to the end here, we call cycle time. After this point, you can start another lots. How can we calculate cycle time? Cycle time equal production time and time width or time when machines are not busy. How can we calculate time of how can we calculate cycle time? We can say cycle time equal T plus time width. Cycle time equal total processing time or cycle time equal Q over D. Q over D. What about maximum inventory? Maximum inventory will be T, this period of production, times production number of units minus in demand or usage. Or T equal, just remember Q over B, this Q over B times B minus D. Or Q brackets 1 minus d over b. This information is just to summarize the idea behind POQ. Next. See the following example. Manufacturing process of item takes 3 days. The production rate 100 units per day. Daily demand is 60 units. What is POQ? It takes 3 days to produce product X. P 100, D 60, POQ equal. See next slide. We have here 5 days, first day, second, third, fourth, fifth. Production day 100, 100, 100. Why you stop here? Because we said the production time will be 3 days. 3 days production, then stop. So production will be 0 here. Demand, each day we use 60, 60, 60, 60. If you produce 100 and use 60, inventory will be 40. If you produce 100 units and use 60 units, so inventory will be here 40, and the previous one we have 40, total will be have 80. 100 minus 60 will be 40, plus 80 will be 120. Here no production and we need 60. We can take 60 from inventory. You have inventory 120 and you will take 60, so the rest will be 60. This is your inventory. And you need 60 and you have inventory 60, so the inventory will be reach 0. Cycle time here 5 days. 5 days. After this you can start new cycle. Some important notes here. Production per day and demand per day must be the same time units, days, weeks, months, years. If D wasn't mentioned, P per day, week, month equal D over number of working days or weeks or month. Production quantity, you see that production take 3 days. This will be T. Production number of production equal 100 units, so 3 times 100 units will be 300 units this quantity. Same if I ask you what the production rate. Production rate will be quantity over T. So quantity 300 over 3 will be 100 units per day. Okay, the same if we ask you to get T equal Q over B. But can you calculate total processing time or cycle time? Cycle time we mentioned. Cycle time here, quantity over D. Quantity 300 over D 60 will be 500. If I said to you 5 days minus 3 days number of production day, this will be equal to, what about 2? To this time width or time when machines are not busy. This is the same what I said to you. This time when machines are not busy will be 2 by the end of this slide. Maximum inventory. Just I use laser here to show you. Maximum inventory, as I said, this will be equal T times P minus D. T, you have T 3, I think 3. P 100 minus D 60. Maybe this will be 120. Another point, the average inventory. We can calculate average inventory, the half of maximum inventory. Maximum of inventory, we calculate this 120, and the half of this will be 60. Next. See, this table summarizes what I said. 100 production, here D demand, inventory, T is for production period, time production stops here, and the total will be cycle time. We mentioned about how can we calculate from setup cost and holding cost, as we mentioned before. Next. And also we mentioned how can we calculate BOQ. Put in your mind, setup cost should be equal holding cost. The same information what I said before: maximum inventory, average inventory, holding cost, setup cost, and the total cost. This is an exercise. If you have H equal 10, S 100, D 1800, D 6 units per day, P production per day 10 units. Calculate the following: BOQ, cycle time, total processing time or total processing time, number of days in which machines are not busy, number of production runs, maximum inventory level, average inventory level, setup cost per year, holding cost per year, and the total cost. Here, just you apply all these equations, which what I said to you. Move to next. Just read and answer, calculate by yourself. The same here. This true or false questions, answer by yourself. MCQs, still MCQs. Example, solve this by yourself. Another example. Third one. And also this. Finally, I deliver to you two models. First one, economic order quantity. Second one, production order quantity. You have many exercises. Solve these exercises by yourself. If you have any question, feel free to contact with me. Thank you. See you in next video.